China has spent years building artificial islands in the sea, but its latest project will not remain fixed to the seabed. This one will float, travel under its own power, and carry an entire scientific community into some of the most dangerous waters on Earth. Officially, China is building the island for deep-sea science, equipment testing, mineral research, and year-round ocean monitoring. But when a research station can move across the ocean, survive for months without help, and keep operating after a nuclear blast, it becomes far more than an ordinary scientific vessel. The project carries the long name of the Deep-Sea All-Weather Resident Floating Research Facility. Shanghai Jiaotong University, which leads the project, also calls it the Mobile Facility of Ocean Science and Technology, or MOST. Its shorter Chinese nickname translates to the Far Sea Floating Island. Despite the name, China will not create this island by pouring sand onto a reef or reclaiming land from the sea. Engineers will construct it from steel as a self-propelled, semi-submersible platform with two enormous hulls sitting partly below the water. This design will give it the stability of an offshore platform while allowing it to travel like a ship. The planned structure will measure around 138 meters long and 85 meters wide, giving it a deck wider than many modern aircraft carriers. Its main deck will rise approximately 45 meters, and the entire facility will displace around 78,000 tons when fully loaded. That places it in roughly the same weight category as China's Fujian aircraft carrier, although the floating island will perform a completely different role. Inside, the facility will contain research laboratories, equipment testing areas, living quarters, medical services, workshops, communication systems, and its own power and water infrastructure. It will accommodate up to 238 scientists, engineers, and crew members and remain at sea for as long as 120 days without receiving new supplies. The island will also travel at a reported maximum speed of 15 knots, allowing China to move it between research zones rather than permanently attaching it to one location. Once it arrives, the platform can stay in place for months while researchers observe the ocean, test heavy underwater machines, and study areas that ordinary research ships can only visit for a limited time. The idea for China's floating research island did not appear overnight. Shanghai Jiaotong University began working on the concept in 2014 when its researchers started studying how China could maintain a permanent scientific presence in distant and difficult waters. Traditional research ships could only remain in one area for a limited period before fuel, food, weather, or maintenance forced them to return to port. Fixed offshore platforms offered greater stability, but engineers could not move them when research priorities changed. The university wanted to combine the best qualities of both systems, a large platform that could remain stable for months but still sail to a new location when necessary. The project gradually moved from an academic proposal into China's national development plans. In October 2021, the government included the facility in its 14th five-year plan for major national scientific infrastructure. This decision gave the project national support, but engineers still needed to complete feasibility studies, structural testing, budgets, and technical reviews. In July 2024, China's National Development and Reform Commission approved the project's feasibility study. Later that year, Shanghai Jiaotong University signed the main design contract with the 708 Research Institute of China State Shipbuilding Corporation, one of China's leading organizations for ship and offshore platform design. During 2025, the project passed further design and investment reviews. Authorities have not publicly confirmed a dependable total cost, although the university has described it as the largest single research investment in its history. China officially launched full construction of the floating island in Shanghai on March 28, 2026. This marked the beginning of the physical building phase after more than a decade of planning and research. Early statements aimed for operation by 2028, but the latest official schedule now places completion in 2030. If China meets that target, it will take around 16 years to turn the original idea into the world's first ultra-large, self-propelled research platform built for long-term residence in the deep ocean. So now the question is, why is it called an island rather than an ordinary ship? The Far Sea floating island may travel under its own power, but its design looks very different from an ordinary research ship. Instead of using a single narrow hull, engineers have designed a massive semi-submersible structure with two separate hulls positioned deep beneath the surface. Large vertical columns will connect these submerged hulls to the main platform above the water. Because much of the structure's buoyancy sits below the area where waves carry the most energy, the platform should experience less rolling and pitching than a conventional ship. This will create a more stable deck for laboratories, cranes, and heavy equipment. That stability will matter when researchers begin lowering machines into water several kilometers deep. China plans to test deep-sea equipment weighing more than 100 tons, including mining machines, underwater robots, drilling systems, and seabed observation equipment. Even moderate movement at the surface can become dangerous when a crane suspends such heavy machinery over the side. The twin-hull design will also allow the platform to continue working in rough conditions. Reported specifications indicate that it can operate in sea state 7, when waves may reach between 6 and 9 meters. Engineers have also designed it to survive Force 17 typhoons under China's wind classification, where sustained winds can exceed 200 kilometers per hour. Once the platform reaches its research area, propulsion and positioning systems will help it maintain a stable location. This means it can remain above the same section of seabed, while scientists carry out long-term observations or operate underwater machinery. Engineers can also move the platform away from an approaching storm, relocate it when a scientific mission ends, or send it to support a completely different research program. That is what makes the facility different from anything currently at sea. It will combine the mobility of a ship, the stability of an offshore platform, and the working space of a small island. Instead of sending scientists on short expeditions, China will take an entire floating research base directly to the ocean they need to study. The floating island's ability to survive typhoons and large waves already makes it an unusual scientific platform, but its most controversial feature has nothing to do with the weather. Chinese researchers have also designed parts of the structure to resist the pressure created by a nuclear explosion. This does not mean the entire island could survive a direct hit from a nuclear weapon. No publicly available test supports such a claim. Instead, engineers have focused on protecting the compartments that the platform would need to survive after a powerful blast. These areas will contain emergency electricity, communication equipment, navigation controls, and other systems needed to keep the island stable and operational. For this protection, the research team developed a special type of sandwich panel. Ordinary sandwich panels place a lightweight internal structure between two stronger outer layers. China's design uses carefully arranged hollow metal tubes and lattice structures inside the panel to control how it reacts when a pressure wave strikes. Heavy steel armor depends mainly on thickness and weight. The new panel works differently. When a sudden blast hits its outer layer, the internal structure begins to compress and deform in a planned sequence. This process absorbs part of the energy and spreads the force over a longer period, reducing the peak pressure that reaches the compartment behind it. Researchers from Shanghai Jiaotong University tested thousands of different configurations through computer simulations. They changed the shape, arrangement, thickness, and angle of the internal tubes to find a design that offered strong protection without adding excessive weight to the platform. Some reported simulations showed that the structure could reduce the force transmitted through the panel by around 58%. The researchers also referred to GJB 1060.1-1991, a Chinese military standard connected with protection against nuclear blast pressure. The use of such a standard inside an officially civilian research project has raised questions about what other missions the platform could eventually perform. There are practical civilian reasons for protecting its emergency systems. The island may operate thousands of kilometers from a safe port, surrounded by fuel, heavy machinery, electrical equipment, and high-pressure systems. A major onboard explosion or another extreme accident could create a powerful shockwave even without a nuclear weapon. However, nuclear blast resistance gives the platform clear strategic value as well. A facility that can maintain power, navigation, and communications after a major attack becomes far more difficult to disable than an ordinary research ship. The Farsi floating island could strengthen China's ocean research, but its importance extends beyond laboratories and scientific equipment. The project will also give China a permanent and mobile presence in distant waters without requiring a conventional overseas base. Modern maritime power depends on more than aircraft carriers, submarines, and missiles. Countries also need detailed information about water depth, seabed terrain, currents, temperature, salinity, underwater sound, and weather patterns. This information supports commercial shipping, resource exploration, disaster forecasting, submarine operations, and underwater communications. The floating island will collect this data continuously for months rather than during short research voyages. It could also deploy underwater sensors, test autonomous vehicles, and map areas of the seabed that China may consider economically or strategically important. Many of these activities have both civilian and military applications. An underwater robot designed to inspect pipelines can also survey strategically important seabed infrastructure. Technology developed for scientific communication with deep-sea machines could later support naval systems. Detailed knowledge of currents and underwater sound can help marine researchers, but the same information can also support submarine detection and navigation. This does not mean China plans to turn the island into a military base. Authorities have presented it as national scientific infrastructure, and no official source has announced that it will carry weapons or naval aircraft. However, the platform's mobility, long endurance, protected command systems, and ability to support large underwater equipment give it clear strategic potential. The South China Sea has received most of the international attention, but China has not confirmed that the island will remain there permanently. Its design allows it to operate across the Pacific, the Indian Ocean, or other distant waters. That flexibility may prove more valuable than placing another fixed facility on a reef. For China, the project represents another step toward becoming a leading deep-sea power. The result will not simply increase China's ability to study the ocean, it could also strengthen the country's position in the global competition over deep-sea technology, critical minerals, underwater data, and long-term access to the world's most remote waters. Now here is a question for you. Will this floating island change how humanity studies and develops the deep ocean? Will the United States and other maritime powers build their own versions? And could China's latest scientific megaproject eventually reshape the balance of power at sea? Let us know your thoughts in the comments below.